me, this is a project a long time in the making. I first started thinking about this problem in about 2012. And here we are now, several years later, and finally it's available. So I decided to talk to you about it and go into details and maybe give you some idea of why it took so long. Okay. So first of all, what is UPSERT? It is a feature that allows you to construct an SQL statement to either insert or update the row. You would update the row on the basis of another version or a duplicate existing. You'd update that existing duplicate instead. You are going to want to be sure, though, that various errors, problems that might otherwise arise will not arise. You want to be able to do this and be sure only one of those two outcomes for each row that you propose for insertion. So you more or less don't have to worry about race conditions. We worry about them for you. Now, during the development of the feature, I sort of invented a piece of lingo, fundamental UPSERT property. And that's this notion that you most definitely only get one of the two outcomes I refer to. You do not, for example, get a duplicate violation, where the entire point was that you could not get duplicate violation rather than update the row. Similarly, the implementation does not allow for another piece of lingo I invented, unprincipled deadlocks, which are deadlocks where there are implementation level blocks acquired, and these deadlock in a way that you, as an end user of the database, would not really consider to be legitimate. What does that mean? Well, suppose you get deadlock conventionally. Typically that's because you do two update statements in one transaction and two in another, and are inconsistent in the ordering. And so you could very well fix that after the fact, and then from that point on get no more deadlocks. In general, this is the case. It wouldn't have done if that general principle did not apply here, if there was deadlocks and the only solution was to just not do so much UPSERT. That would not apply. So it doesn't do that. And so it's kind of driven by an insert. We'll see that in a moment when I show the syntax. I should also note that MySQL's insert on duplicate update meets this particular standard. So it's important that we make the feature as simple to use as possible. And I think we accomplished that. Now I'll actually show you the syntax. So what we see here is some example statements. These are all insert statements, but they use the new clause that extends them to provide UPSERT functionality. The first is a simple example involving upserting two rows. Each could be inserted or updated individually. So the second example shows an insert ignore type statement, similar to MySQL's insert ignore, but spelled differently, as you see. And then the third example shows more sophisticated UPSERT, where we have an additional condition on the update. So in the event of a would-be duplicate violation, take the alternative path, the update, but then we only update on the basis of that further condition passing. It'll always lock the row. That is the row that would have had the update applied, but then necessarily actually be updated, as I said. Do nothing, on the other hand, does not have this property. It will not update that row in the event of having to take its own alternative path. It will just do nothing. Here I'm showing you the excluded pseudo table, modeling that here. This is showing you how we might reference the values that you see here originally proposed for insertion in an easy sort of way. Now, if we didn't have that facility, it would be sort of tricky to get this right, because we have, for each row proposed for insertion, this is a variable, so it'll be either gizmo, translatable, or associated computing, depending on which row is being updated, if any. So it carries the effects before insert triggers, because those effects may have in fact contributed to the row being excluded from insertion. Minor detail. This sort of feels like, so updates have always supported an update from syntax where you update a particular target table, but you use another table for a join. And so you update the target table with reference to that other source table. This excluded thing feels a little bit like that. It's sort of like there's an implicit join to an imaginary table that serves to do just this. So it feels just like that, except it's implicit. You're not doing update from, update target table from other table, but it's almost as if you are. Here I highlight what I call what we all now call the inference specification, or this is a part of this is a mandatory part of the on-conflict to do update here, and this is one of the columns we see in the distributors table. And what this means here is we are figuring out, based on that, which of any available unique indexes or constraints to use to take the alternative path on. We are being explicit about what our intent is. So this is something that I think is a pretty unique kind of differentiator for us here. We are determining that we need to do it for that one unique index, and only that one unique index. Any other unique indexes will continue to have conventional duplicate violations, should they be violated, just as you'd expect. If that wasn't true, if you were assuming that the first one that you happen to see was always the one you ought to take the alternative path on, then there are cases where you could get basically logical corruption, where you would accidentally get a dupe violation in some other constraint, and then you would update what is in fact the wrong row. So we avoid that here by letting you be explicit about what you mean. Like I said, this is mandatory for the to update variant UPSERT, although not for the do nothing variant, where we feel you could reasonably not particularly care about, violation occurs. You can sort of have a general idea that it doesn't work, okay, move on. Okay. So I always encourage people to use inference. There is, well, you don't see it here, an alternative on conflict on constraint name thing, which will allow you to spell out the name of what you mean to take the alternative update path on. But that has problems in that it's not as flexible as this approach you see here in inference, because of things like migrations happen, and there's a variety of kind of subtle border cases that are avoided just by using the inference, using inference rather than using that explicit on conflict on constraint thing. So this is sort of very flexible and forgiving. As I like to say, it's easy to use correctly and hard to use incorrectly. The indexes that are involved here are sometimes known as arbiter indexes, in that they have the authority to determine whether or not we should take the alternative path. They will actually appear in explain output, which we'll see a bit later. Okay. So a lot of people have asked me me why don't I go and implement merge instead? It is, after all, in the SQL standard. Why go and invent another thing that's non-standard? Indeed, this isn't quite like anything else in any other major system, although there are features of other systems that are somewhat similar, as I mentioned already. Well, that's a good question. I think the answer is essentially that people didn't want merge, and merge is legitimately a distinct sort of feature. I'll go into the details of why that is now. So merge is really about synchronizing two tables, inserting, updating, deleting the target table from source table, reconciling the two tables. It's not especially anything to do with UPSERT, contrary to popular perception. So it appears to be UPSERT-like, but in fact isn't. It, as I would put it, lacks this fundamental UPSERT property. It can, for example, have dupe violations in the very place you expect it not to have them, just because it has race conditions. But they aren't really race conditions, because the vendors don't actually tell you that that's not supposed to happen. Maybe it's implied, but they never actually tell you that. So you can't really be sure that you write the statement and that's it, you're done. It's rather ticklish in practice. And so I was very determined from an early stage that my implementation, or our implementation, would not have that problem. And it doesn't. We do, however, offer some kind of merge-like flexibility. You already saw the where clause on one example. That's a little bit like merge. Although everything is in terms of a would-be duplicate violation. It's not an arbitrary join with an arbitrary joint condition. Merge is still useful. It's good for data warehousing and stuff where you're reconciling these two big tables. There could be an awful lot of rows involved, and it would tend to be more efficient in practice to use what is under the hood a conventional join. Okay, this example shows an UPSERT statement as would have been implemented before 9.5 using an ad hoc sort of workaround. So, do I get a show of hands? Anyone familiar with this particular pattern in the room? Okay. This would be the correct way to do it before, although there are many incorrect ways too. I've seen plenty of them. It's a little bit, the print is a little bit small. This is directly lifted from the documentation. But what it's showing you is this is a PLPG SQL function. Starts here, so there's a loop, and there's no condition. So this loop could, in principle, you could have more than one loop of this. You could have several. So what we're first doing is we're updating, and then if that affected a row, then we return. If it doesn't, we start a sub-transaction, we insert, and we catch any duplicate violation to prevent it from being raised, being sent to the client. And if that happens, then we start from scratch, try the update, try the insert again. So this is kind of ugly, but it does have these various properties I described. It does guarantee an insert or update. It will try forever if it has to, although it won't have to. It does the right thing, although it's very error-prone. It's pretty ugly and has some pretty obvious disadvantages. It burns through transaction IDs. So on the subject of merge, again, this next slide I think illustrates my point about it nicely. What you see here is an example. This is something I lifted from the Stack Overflow page. This example shows how you might get these guarantees using, in this case, Oracle with merge. What you see here is a merge. If it was only on its own, you might reasonably imagine that you're getting UPSERT-like semantics with it, but you're not, and that's why this person recommends you do really the same pattern as you would have had to do prior to 9.5 with Postgres, where you have a sub-transaction, you're prepared to handle these cases, and you're prepared to loop. So in fact, it's exactly the same, except you just reconcile the insert and the update to one statement. Nothing has really changed, because merge is playing more or less by the same rules as any other sort of DML. summary, UPSERT's about guarantees about outcome. There are some tricky points implementation-wise there, but it's all about guaranteeing a certain outcome, whereas merge has no sort of trickery to guarantee any such outcome, but useful for bulk loading, useful for data warehousing, that sort of thing. I mentioned here visibility. So UPSERT necessitates, getting these guarantees necessitates special rules that are peculiar to UPSERT to guarantee that you always get the UPSERT update. So in that sense, it's a little unusual. Okay, this next slide is a bug that MongoDB. Someone told me about this. I think it's an interesting example. I'm not generally in the business of bashing MongoDB. I don't know very much about it. But what's interesting about this is that it shows you a regression that they had, and still have, in fact, this bug is open, where prior to the introduction of their wired tiger storage engine, they had blocking that was not very granular, whereas with that, they have more granular blocking. I think they call it document level blocking. And as a consequence of that, now when you UPSERT with that, you can get duplicate violations, even though UPSERT is supposed to avoid those particular duplicate violations. So, and there was also early problems with MySQL here. I don't believe it's currently a problem, but you know, my early research on this showed that MySQL would have similar issues with spurious dupe violations. So I think the fact that they've accepted that this is a bug sort of illustrates that this is really what people want, what they expect is a guarantee. That's fairly clear. Okay, I'm now going to do a summary of UPSERT in general. It has a very flexible syntax. It's far more flexible and far less error-prone than the comparable MySQL feature. MySQL, of course, doesn't have inference. It doesn't provide you with a way of spelling out what you want to take the alternative path on. And we believe that the fact that we do have that is an important differentiator for the Postgres version of this feature. I mentioned already it's about guarantees, and that there are special rules with regard to MVCC just to suit UPSERT's purposes. Okay, so you have to always be happy with an insert, though. It's driven by an insert. So with merge, you can reasonably have a handler for when there's a conflict, or when there's no conflict, and do nothing. So whereas with UPSERT, you have to be happy with the possibility that you might insert. So you kind of need to leverage that to get the guarantees, if you know what I mean. Otherwise, it becomes very spooky and Heisenberg-esque, and I could go on. Okay. The SQL standard doesn't require very much in terms of concurrency in general, possibly even nothing. The concurrence, they're very vague about what is required of any implementation. The SQL standard doesn't even have anything to say on indexes, considering it to be an implementation detail. Merge, in any of these other systems, doesn't require an index, which is useful perhaps because you don't, if you're doing bulk loading, maybe you don't have indexes created yet. It's common enough for data warehousing to create indexes afterwards. Okay. With that, I will take questions on what you've seen so far, UPSERT in general. Does anyone have any questions tonight? Yes. Sorry, can you wait a second? Yeah, please. Mike here.
My question about on-conflict clause. Can I specify it 2 times for 2 different cases?
A lot of people will ask that. The answer is no, but I think that that's because it gets tricky when you have more than one, because then it's not clear what happens when you have both violated at the same time, or it's not clear what the combination of the two at the same time would be. Also, if they were contradictory, it wouldn't be clear which one would have precedence. So what I tend to say when the issue comes up is that maybe just have two insert on conflict, and that would, possibly that would satisfy that use case. So the answer is no, as implemented for these sorts.
Okay, but I can have in table many unique indexes. It will work. No, it's with.
Oh yes, it'll work because.
But it will. I can specify on conflict only for one of them.
Yes, that's right.
Okay, thank you.
How flexible is what you can specify on conflict? Like, can you increase a counter on the row instead of inserting or updating?
I guess. Well, the answer, first of all, is no. You can only specify a constraint. It could be an exclusion constraint. We'll talk about that in a little while. It's not quite the same as a unique index, but it's similar. Or else it's a unique index / constraint. I know MySQL insert ignore will also ignore not null violations. I didn't really want to go there because I felt that that's the kind of thing that's fundamentally kind of on you to just not insert a null. Whereas this, you can't just give the responsibility to the user because it's too complicated. It involves things that are happening concurrently, which you don't conventionally know to be there. So I felt personally that wasn't the semantics that I thought were most useful. So I can understand why you asked the question, but in fact, it's only data sort.
I don't think that's quite the question. I think the question is, can you do set column or column plus one?
Oh yeah, of course. Yes, you can. Sorry, I don't know why I thought that was. Yeah, you can totally do that. You can do subqueries, and you can do, correlated subqueries and everything. In fact, it's extremely flexible in that regard. There's very little, in fact, no restriction like that whatsoever. Unlike merge, by the way, which doesn't let you put subqueries in a lot of places. So it's very flexible. Is the answer, I think.
One more question.
And what if conflict fields are not one but three?
I'm sorry?
The conflict fields.
Yes.
It's not one field, but
you
three
mean
fields.
if it's a composite index?
Yes.
Then it's pretty much the same as when you originally specify what they are in grid index. You just put, field 1, comma field 2, comma field 3. That works just fine. And you can also do a lot more than that. We'll see that in a little while. Is that it for now? Or? Yeah.
Running.
The interpreted insert creates a dead row. Is it possible to clean that up? And does the update?
The answer is that's basically not the case. It's possible. Okay, so it's actually pretty similar to the example I showed you from the pattern with the looping. You actually do the update first, and if that doesn't find anything, there's no dead row. And in fact, it's almost certain that you'd either initially find it, or would then insert it and have that be how it was resolved. It's much less likely that you would have to restart and have a dead row. It's possible, but in practice, it's probably very unlikely. Okay. Anything else for now? You can ask questions at the end if I've got time, but I might not. I mean, not up there in general. There'll be, or I'll continue. Okay, now I'm going to talk about new use cases. I'm introducing the concept of data integration. So this is just a general concept about integrating data from diverse formats with diverse sources that are not exactly under your control. So you have a mediated schema where you're taking all this diverse data and you are making sure that it's all stored in a format that sort of bridges the gaps, makes everything, these diverse sources, represented in a common way for obvious reasons. You can have like different types of what you might call it coding. Maybe it's different units of measurement are in use. Maybe something else. And it's complicated. It's messy, but it's the reality for many people. Okay. So when you're dealing with all this complexity, idempotence is an important property often, which is to say, it can be important that UPSERT statements can be executed multiple times without changing the result beyond the initial application. This could also apply if you're using a system like Apache Kafka, which makes no guarantees about delivering messages more than once typically. So it expects you to be able to roll with having messages delivered more than once. So in that case, it would be most unfortunate if there was no easy way for you to just deal with that. But I'm leading with a more sort of traditional business process sort of example here. So if you wanted to do this conventionally, maybe you were able to fence the data that you're maintaining. That is, maybe you can somehow eliminate the possibility of current activity, but maybe that's inconvenient, and maybe not, and maybe it's difficult to get that right consistently because of practical considerations. So this is where UPSERT can be important. The guarantees, that is. My perspective, and this is kind of me just taking a general philosophical position that's sort of high level, that even if you are an expert, it doesn't. It's also true that your chances of getting a lot of this stuff consistently right are not great. And besides, that's only the best case. Even if you understand how these conflicts can come up, chances are good that you won't get it right every time, because when does anyone get anything right all the time? So here, as elsewhere, we have one simple abstraction that provides guarantees that we can leverage to the hilt again and again. We'll be a lot better off. And that's really the big picture here, what I'm really trying to emphasize in all this. ETL, it was always a problem, but meshing the complexity of different production systems together is when it gets really clear. Kind of a new primitive, sort of the other missing type of DDL. So I'm going into this example, accidental distributed system. This, like I said, doesn't involve Kafka, it's more sort of prosaic. Anyway. So imagine, if you will, a system where a retailer has disparate suppliers of products. Those suppliers are themselves probably in competition. This ad hoc system will probably use, in each case, different sorts of files that encode details of products. Probably something as terrible as comma-separated files, that kind of thing. And just business being what it is, there's no particular incentive to standardize. It's very messy. Each autonomous system, which is to say a wholesaler of products, controls individual details of products, passes into, for example, a description of the product, and could be interpreted as applying to any instance of the product, including instances where the other wholesalers are in fact supplying it concurrently, that kind of thing. So it's not quite clear what the authoritative version of it is. We have to sort of smooth all that together, smooth that out somehow. Working at the example a little bit more, we see a products table, which has products common to all of those suppliers. We have suppliers themselves and the prices that suppliers sell the products to the end retailer for. Okay, so this kind of, because the wholesalers are in competition, they don't really have an incentive to standardize at all, and they're probably happy to sort of implicitly assume that they're the only supplier you're getting the product from anyway, even though of course that may well not be true. So need to allow for changes in product name, say, and we need to have some notion of controlling for conflicts between different suppliers. So here we see an insert into the products table, and we go on to update. So that update is conditional. It must be that the target table, last updated at, has a last updated at that is less than the most recent authoritative from date. What you see here is in the list of proposed for insertion. So we're thereby ensuring that we don't update a product if in fact a more recent update has occurred. So you know, this is sort of a way of both maintaining, here's a list of products, here's facets of the product that are generic. These are products that have probably the same UPC barcode, but can be purchased from any of these suppliers, and maintaining those disparate from disparate data sources, you know, and further doing it in a concurrency safe way and getting it all for free. That's sort of what I'm going for here. That's what I'm sort of pointing out. And I also haven't picked a particularly glamorous example. I think that's sort of middle of the road example because I suppose if you are one of the cool kids that's using Kafka or whatever, maybe you'll account for that. But you know, a lot of developers maybe don't have time to concern themselves with that. They're too busy getting things done. You know, focusing on what's important to business. So these two will equally benefit. Okay. Now I'm going to talk a little bit more about advanced capabilities of the feature. So we've seen already how UPSERT can selectively update a row. But there are further details still, further edge cases, further possibilities. Something that's very important here for me is that the feature works seamlessly with everything else. That be, you know, first-class citizen, I suppose, unlike the historic workarounds that I already showed you, that things just work. So here we see a further worked out example where we are we're inferring now a partial unique index. So to take a step back for a moment, suppose in the system you have a concept of logical deletion of products. You must ensure that among products they have for each supplier a unique product code that the supplier requires you reference when ordering products, that sort of thing. What happens when you need to logically delete products, but also those products must still be present in some sense for the benefit of historic sales records. You might, for example, delete a particular product and then some years later you get it becomes available again, you need to put it into the system again. You need to have two copies of it in essence, one representing the earlier timeline, but you can't very well have a conventional unique index because the product code might be the same, the UPC barcode might be the same, etc. So how do you make it all work together? Well, Postgres allows you to do this in general by having a partial unique index. You can easily have a predicate when you do a create unique index rather, and with that you can be sure that once you, so you have an is active column, and you represent the product as being logically deleted by setting that to false, where usually it was true. You can then be sure that yes, the old products will still be there for reporting purposes, but at the same time, the constraint will only be enforced among products that are current. But where does this leave UPSERT? Is the question, is where I'm going with this. Here we see another where clause, where is active, which is what I mentioned. Now note, in particular, this is part of inference. This is participating in inference. It's not the where clause you saw earlier. there's no such where clause here. There could be one here. We could have an additional condition where whatever, this where clause is here, thus indicating that when we're figuring out what unique index to use, we should be content to have it be one that has that predicate on it, although in fact it wouldn't matter if it didn't, because it works in a way that says it has to have at least this and not it has to have exactly this. Again, flexibility. Okay. So safety first. I already said another one of my things I like to bring up. Easy to use correctly, hard to use incorrectly. It is somewhat unusual that the semantics of a query depend on the presence of a constraint. But having offered what is in fact a novel new thing that you must spell out what you mean to take the alternative path on, having, in the case of toUpdate, insisted upon it, requiring you to use it, it sort of was very important that at that point we didn't give you a new novel way of shooting yourself in the foot. So we'll go into why that isn't the case either in a little while. Okay. So this is something I briefly referred to earlier. Explain output for an example statement. And this is showing you some details that are new and novel. It might be that some of you weren't aware that you could explain an insert or an update statement. You can, you always could. This, of course, is showing an UPSERT being explained. It's showing you that the onConflict clause inferred one particular unique index UPSERT PP, that the conflict was resolved with an update, or would be resolved with an update. This is not an explain analyze. If it showed you an explain, if I showed you an explain analyze, it would show you how many rows were inserted or updated. But that isn't an explain analyze, so it's not true. Okay. Now, what I haven't mentioned, although I alluded to it by mentioning edge cases, is that you see one index here, but occasionally you might even see 2 or 3 in the event of a migration, something like that. We see a little of that here. So because we have a predicate now, where it is active, suppose we traditionally, we did a migration to have that unique index be a partial index, so we're doing a create unique index concurrently. We have 2 unique indexes at the same time. So we're saying where is active is sufficient. So we can now infer this create index that we created, this index that we created or are creating concurrently, in addition to the primary key, as they overlap, although only one has predicate. So we're doing 2 of them at the same time. Now, granted, this probably wouldn't come up very often, but it might, and when it does, it hopefully won't explode. So now it doesn't explode. So again, we worry about these edge cases to a large extent, so you don't have to. Okay. And inference gets pretty advanced. It also supports expression indexes. General Postgres does not restrict you from only having unique indexes on columns. It can also be on arbitrary multiple expressions. For example, it could be lower, use the function lower to make it all lowercase. If you want a case-insensitive thing, there are many possibilities. That's certainly not restricted here. The inference, onConflict with inference is very forgiving of redundancy, ordering of columns as they appear in create index or in the statement. You saw the predicate thing. Again, to emphasize, use the inference specification. Don't use onConflict on constraint name. It's way better to use inference. Although there is one thing to be said for onConflict on constraint name, which is that if you do nothing and you want it to be on exclusion constraints, you need it there. But I referenced exclusion constraints earlier briefly. Let me tell you what they are. Specific constraints are sometimes explained as a generalization of unique constraints. You might consider that a unique constraint applies to quality only. So, quite simply, you can't have two duplicates of something at the same time. That would represent a violation of the constraint. We can generalize this to other operators that are not quality. For example, in event management, we might have bookings, and we want to avoid double bookings. So right now we're in this room, we're occupying this room, no one else is allowed to occupy it. But what if we didn't want to have discrete buckets, we didn't want to have distinct buckets of time that everyone had to operate in? What if instead we wanted to have arbitrary ranges of time? We can still have that and still ensure in a similar way to unique constraints that it was not possible by using exclusion constraints on an overlaps operator, preventing overlapping sessions, even though that could be down to the second. So, kind of an independent, cool example of Postgres making this sort of complicated data integration stuff very easy, but it works just as well as anything else with do nothing. It works just fine. So, everything works. Okay. Postgres foreign data wrapper supports do nothing variant only. Postgres foreign data wrapper is an extension that creates an abstraction that allows you to have in your Postgres database what appears to be, in many ways, a Postgres table, but in fact is on another database, another Postgres database, which we transparently connect to and make further changes to as changes are made to the local table. It's more or less a way of abstracting that away. It supports the do nothing variant only simply because there's no existing notion of a unique index on a foreign table in your local database. But that's really the only reason. It will, I suppose, allow you to, you know, if you've got a complicated production system, it'll bridge a lot of gaps. Very useful for that. Another major feature in 9.5 is called RLS, row level security. That's a way of having it so that traditionally you had permission system that applied to columns. Row level security, of course, applies to rows instead, or as well. It is very useful for multi-tenancy, for making it so that you have a way of having tenants that are only, or potentially only represented in the app, having those tenants only see rows based on arbitrary conditions. A very flexible way of securing your data. And again, it works just fine here. It'll do the right thing, although there are some special notes on how that can work in detail in the RLS documentation for straight policy. Datable views, another feature that allows you to have a view implicitly have an update rewritten to update the underlying relation. That'll just work again. And really, there's really no notable example I can think of some existing feature not meshing together nicely with this. Kind of one of the reasons why it took so long. Okay. Logical decoding plugins, some of you will know, produce logical change set records. You can produce a list of changes for many different purposes, including logical application with those plugins. That will represent the insert or update as either an insert or an update, and not specifically as an upsert. In 9.5 also, independent of all this, there is a new way of having an update use a subselect, so you can say update table set, and then in parentheses some list of columns, and then equals, and then a subselect mentioning multiple columns corresponding to the target list columns that you're updating. That just works here transparently, of course. I also mentioned flexibility. Your where clause can have subselects, your target list can have subselects, those subselects can be correlated, but using excluded, there's really nothing that does it work. Okay. Postgres supports something that sometimes known as common table expressions. You might know them as with clauses, where the duration of a query, you can use a with clause to sort of specify what is effectively a table, temporary table, but only lasts for the duration of that query. So you can sort of pipeline things and deconstruct the query in a way that makes it easier to understand, that kind of thing. So that's something that is in the standard. So I think SQL Server has it, Google has it, whatever. We have it too, but we also have something else which isn't in the standard, which is somewhat novel, which is the ability to have those with those common table expressions contain not a select, but rather an update and delete. And you could pipeline DML that way. There are many possibilities here over and above what is possible in those other systems. So that you can pipeline, you can do UPSERTs there. It's all better. That happens with the returning clause. Some of you will know that inserts, updates, and deletes will accept this returning thing. Again, not the standard. That'll basically select those rows that were affected. Say it's an insert, it will show you the rows that were inserted. So the question now is, what happens if it's an upsert? In case of an upsert, it will either show you rows that were inserted, or alternatively, rows that were updated. So we're going to see everything there. It all works. Okay. And I think that's all I have time. That's all I've got prepared anyway. I can take additional questions now. How are we for time? 10 minutes? Okay.
So all in your examples show values clause as a source of data. Is it possible to pass select?
Good question. Thank you for asking. Yes, it is. You could have a select. It's like as many rows as you like. So that's how inserts work, and so that's how this works. You can select from another table. You could do all kinds of things to get the rows that you are putting into the insert, and then maybe update it. So yes, very flexible. Nothing like that at all. It works for insert. It works for export. Any others?
If I have a long insert list with lots of columns, do I have to replicate them all in the new update clause? Or did you think of implementing some on new update? What do you mean, well defined?
If you want to leave now, try to do it quiet.
If you have a table with multiple constraints, can you have multiple on-conflict clauses on the same inserts?
That question was asked earlier. The answer is no, but it would be possible to. Well, the reason the answer is no is because it's not well defined which one you do first, what happens when the code could be violated, that kind of thing. And in general, I recommend people instead consider using two insert on conflicts as appropriate, and then resolving all those ambiguities. Anything else?
So
I think
use
that would be
case.
fine. Yeah, you wouldn't use minimum maximum because they're aggregates. Rather, you'd use least or greater. But yes, that would be perfectly fine. I would have anything really makes sense for your use case. There's no global restriction. Further questions? Okay, am I done? No.
That's about it. Thank you.
Thank you.